In this tutorial, we're going to apply the techniques we learned earlier to extract the data out of a graph that we find on the internet. We're going to expand that technique on the bottom graph to extract the boost data and recreate an Excel spreadsheet of all the boost data in this image. We're going to do this by applying the same four-step process that we learned in the previous demo. Step 1, remove all the background material. Step 2, convert the image to black and white. Step 3, export the data to Microsoft Excel. And step 4, import the data to Microsoft Excel and graph it. In order to have the best chance of success with this graph, we don't want to leave it in JPEG format. If we leave it in JPEG format, every time we save it, it might introduce color artifacts. It may appear black and white to us, but there still may be hundreds, if not thousands of colors, almost white, almost black, that would appear in it. So in order to reduce the possibility of that happening, we're going to save it as a PNG file. And then we're going to work on it and do much the same thing that we did in the previous example. We're going to start removing all the background material. As it looked in the previous example, this may look a little bit odd, but it's designed to remove all the unwanted material from this graph. In a matter of 1 or 2 minutes, I've managed to get this graph down to just the bare essential material. What we're going to do now is we're going to continue to go into this graph and we're going to dive into it a little bit deeper using the same paintbrush technique to remove these crosshatch lines. In this case, we need to go a little bit further. We need to zoom way in. If we convert this image to black and white now, I will quickly lose sight of where the crosshatches are because they contrast black and white with the colored material. So by leaving it in color for now, it'll be much easier to remove the crosshatch material. And after about maybe 10-15 minutes of this, it looks like we got the boost graph down to just the boost data itself. The small black and white dots that appear to be artifacts in there are actually part of the original graph. So while they may appear as artifacts, they are actually drawn right on top of the original boost data lines. Next, let's convert this to black and white. Converting this image to black and white is going to be a little bit more complicated than our previous demo. In our previous demo, we started with a black and white image and all we had to do was make sure that it stayed black and white. In this example, we're starting with an image that has 7,200 colors in it. Even though they mostly all look white and maybe some pink and gray, there's really 7,000 colors there. So we're going to go back to ImageMagick to convert the data once again. We're going to tweak the parameters a little bit from last time. For more details, look at the ImageMagick tutorials that are available online. This is just a modified version of one of the tutorials that exists online. So once we bring up the file back in our graphics program, we can get a better idea of what it looks like. It really looks like it's black and white, just like the original. But when we count the number of colors, we can see that there's still 1,256 colors there. So we're going to use Paintshop Pro to decrease it one more time. Instead of using ImageMagick, we're going to decrease the color depth to 2. I've modified some of these parameters for the best results. And after I'm done, let's check it one more time. And we can see that there's now 2 colors. And so lastly, what we're going to do is we're going to save it as a new file so that we don't overwrite any of our previous work. Now that we've got our black and white data, we're going to go back to ImageMagick to convert it to Excel. We're going to use the same exact parameter that we had last time, converting it to Microsoft Excel. Once I've converted the data to Excel format, I'm going to go back to Excel and I'm going to import the data just as we did before. We're going to look for our evboost.txt file, and just as we did before, we're going to call it delimited data. We're going to select comma and space and click finish. We're going to delete column C, D, E, and F, and then we're going to resort the data from lowest to highest. Just remember, before we can graph the data, we have to fill in the canvas size, overlay size, and offset locations of the overlay. So I'm going to fill in that data right now. We can see that the image is 1024 by 422 and there should be no offset, so it'll start at 0, 0. Next, we need to capture the starting and ending RPM data. We can see at 1500 it's at 68 pixels and at 9500 it's at 962. Then our boost data, 1 psi is at 367 and 11 psi is at 46. We're going to transfer those data now to the spreadsheet. Now the last thing that we're going to do is we're going to import the data itself. We're going to go back to the spreadsheet that we had right over here. We've already highlighted the data. We're going to Control-C to copy it. And then I'm going to come back over here to row 6 and I'm going to paste it. When I do that, we only got part of the data because the formulas to calculate the rest of the data have not yet appeared. So we're going to highlight those formulas and we're going to copy the formulas all the way down to the end of the spreadsheet. And then as one last final step, before we're done, we need to change the graph so that it will display all of this data. So we're going to go back up to the graph. We notice that the last of it was at about row 6300. So we're going to edit this. We're going to change the ending point to 6300. And now we have a beautifully formatted graph on the screen that has all of our boost data that was extracted out of this Dyno chart right here. The last thing we're going to do is we're going to add in our trend line. We're going to add in a linear trend line into this, and that will help us estimate what the actual boost is for these Dyno runs. As one final sanity check to this tutorial, I'd like to overlay the original graph on top of our regenerated graph to see how close they match. I not only want to see how close the graph lines themselves match, but how close the axes match as well. So I'm going to add major grid lines so that I can see how well the RPM axis and the boost axis matches this graph. I intend to overlay this graph on top of my regenerated graph to see how well they match. However, when we look at these two graphs, we notice that they're two different sizes. So what I've done is I've calculated what those differences would be in this area of the spreadsheet. So I've done all the math to find out what canvas size it should be. So at the bottom of this highlighted area shows that I need to resize the internet graph to 1157 by 706. So let's resize it. We're going to resize to 1157 by 706. There's 1157, 706. Click OK. Then we're going to copy it. We're going to paste it as a transparent image right on top of this graph. And when we're done, we can see an exact mirror image of the original graph that we found on the internet to our Excel regenerated graph. And when we look down at the RPM axis, we can see the grid lines of our new generated graph match exactly the grid lines of the previous graph. And when we look up the boost axis on the right-hand side of the graph, we can see that our grid lines of boost match exactly the grid lines of the internet generated graph as well. So this is conclusive proof that we can extract the data from the graph that we find on the internet, regenerate it in Microsoft Excel, and get the exact same results. So let's recap. When we find a Dyno graph that's on the internet that we don't have the source to, we don't have the DRF files, you can use this technique to extract the data. In this case, I wanted the boost data because I wanted to use it for my BMW Dyno database to figure out how much boost this supercharged BMW M3 was running. I used my 4-step process. I first removed all of the background material that I didn't need. Second, I converted the image to black and white. Third, I exported the black and white data as XY coordinates, which I could then, fourth, import back into Microsoft Excel, graph, add a trend line that I could then extract and use in the Dyno database for boost data. In the next tutorial, I'll show how to take this process one step further. Let's say we don't care about the boost in all 8 of these Dyno graphs. We only care about one of them. So I will show how to trace the one single boost line that we want and generate an image overlay of just that one trace, which we can then use with the same technique to import back into Excel and graph the linear boost. Thank you for watching.